Hello everyone and welcome to another video. In this episode, I'll be working on collisions. So this live coding session is happening at almost midnight, so a very late night session. So if I sound a little bit sleepy, that's the reason. So I want to begin by explaining my idea in terms of collisions between actors and solids or actors and actors. In this case, I think I'm just going to implement actors and solids, and then I can think about if I actually want two players to collide with each other. Maybe that's something I don't want to have, but let's see. So I'm going to use a technique um, that it is supposed to work independently of the frame rate. So if a frame takes 10 seconds to render or 10 milliseconds to render, it is always going to work, right? And it is supposed to be very fast as well. So the only downside of what I'm going to do is that this technique only works with axis aligned boxes. That is basically what you currently have because of Rayleigh rectangles. They are basically forced to be aligned because they only have a starting point and then a width and a height. But besides that, besides not supporting rotations, they are actually pretty good. So I'm basically going to explain the algorithm in Paint, and we can implement then it in C. So let's imagine we have our player. I can actually use this rectangle tool, can't I? Yeah. So let's imagine we have this player, right? And this player, it is floating points, right? It doesn't really matter if it is float or integers. This algorithm is going to work with anything. But basically, we have this player, and the only thing, let me actually make it a little bit smaller, like this. Okay. So basically, if we have one player, we need to check four things, right? We need to check the blocks or the tiles that are above it, basically the solids that are above it, and we can draw like this is a tile, for example. And then we need to also check the tiles that are on the left side of the player. Boy, paint is really not good. Okay, so let's imagine we have like these three tiles in the left side. We also need to check the solids below it, right? And then on the right side as well. Oh my. Okay. So let me just end the drawing this. Okay. So basically, you just need to check for things, right? And all of the tiles that are in this place, in these sections, they don't really need to be checked because we know for sure mathematically that it is impossible for them to be in contact with the player, right? We only need to check things that we know for sure that may be in contact with the player, right? If we know that this specific, where do I set the pencil? Okay, if we know that these specific tiles will never be in contact, oh, this one is, but these specific tiles will never be in contact with the player, then this one is, then we don't need to check them, right? So we only need to check where the cross is, right? And furthermore, um, basically we need to check things in a way such that the speed of the player, the speed of the actor itself, does not influence the collision, right? And what do I mean by this? So, most or some algorithms that people use when they are starting to program in a game. Well, can I? Why? Can I? Yeah, can unzoom. Then I can probably stretch this. Okay. So basically, let's imagine we have a player here, and we have something like a box here, right? If the player is moving at a ridiculous speed, like say 1000 kilometers per second, and we update the player in a single step, then the player may skip the collision check with this box, right? So that's why some collision algorithms they don't really work because of this reason. So what we are going to do is to check a maximum step, and we need to check it until we basically fulfill the entire distance that we want to cover, right? The entire delta. And this minimum distance is basically going to be the minimum the distance of the smallest object we can possibly have in the game. That's the only way you can guarantee that we're never going to skip collisions, right? By just stepping through this distance in steps that have the size of the smallest object in the game. So that's basically it, right? That's not no big secret to it. So in here, oh, and by the way, I actually just been doing some, like I mentioned, like offline, I just changed stuff, uh, the names and put it in like in proper modules, and overall just tidying up stuff, right? Not a big deal. I can show you the changes, but nothing new. Literally, just moving code around, right, and renaming stuff. So just to make it a little bit more tidy. So we can probably remove this. So this code that I want to remove is basically um, the code for this blue and purple thingy, right? Because these are just to test that we actually support multiple actors, but we don't need this anymore. And we basically want to create a function, right, that allows us to update some actors, or the all actors actually. And so since we are now introducing collisions, I actually want to introduce with it the concept of speed, right? I think that's going to be beneficial for our game because it's going to allow us to have more realistic physics, to be honest. So next to our box, we can probably have a field that's going to be just speed, right? And this is going to basically be the current speed of the actor, right? So if that is the current speed of the actor, and we assume that that speed is already like properly initialized and it already changes with the user input that we will still need to change in this episode. But if we assume that, we can then probably create a function, something like move actor. Yeah, we can create a function move actor that is going to accept an actor by pointer, right? And basically here we need to check those four things that I mentioned, right? So left, top, right, and bottom. So to check the left, right? To check the left, we basically need to do something like, so int, I can say left x, right? And what did I just do? Okay. Sometimes my keyboard really is messed up. But so we have the left x that is going to be the actor box x truncated, right? Yeah, so this is already going to work, I think, because let's say we have a grid of tiles, something like this. It's the same thing with the first one, really. And the player is here, okay? I can truncate this x, and this is going to snap into here, and this is going to be aligned with the tile, right? So it's fine. Yeah, so that's going to work. So let's just have this to be like left, right? And now we're just going to implement collisions for the left side. So the x is going to be constant, and the y is going to start here, right? And then move all the way down. So it's going to move from top to bottom. So I can say that y equals to, and this is going to be equals to actor box y, and this is going to be the y at the top, right? And this is going to truncate, so it's going to snap it properly, or no, actually not, because let's say I have this y. Oh, but this is, yeah, this is gross negative, right? So if I have like 10.5, this is going to be 10, which is going to be this one, this line here. Okay, it's correct. So this goes from there into y is less or equal, and here I need to have something like a and y. Yeah, I can call it y. What am I doing? That's very strange. It's jumping around the enter. But yeah, so I can have this, and this needs to add the actor box height, and now I need to, so if this point, well, I can check that, but that's not really necessary. I think I can just truncate it, I think. But maybe I need to actually seal it. Maybe we need to seal. We'll need to check that, right? Only testing it. Well, we could run through the maths, but I don't really feel like doing that at midnight, so we are just going to test it. So, yeah, and then I can just do y plus plus. Right, so this is for the left side. Cool, so here, now, what I need to do is basically just check app dot terrain dot actually this is left x and this is y, and now I need to check if it is collidable to begin with, right? So I can have a function. I can say solid is collidable, right? Actually, I can accept the solid right away. Yeah, I can probably accept the solid itself. And then, well, what solid is collidable if it is not an air block. Where are my solids? Why is it okay? If it is not an air tile and it's not background, right? In other terms, a solid is not collidable if it is an air block or it is a background. So we can probably just use that condition. We can just say solid dot type equals solid air, or solid dot is background, and we can just negate this. So this is probably more maintainable because I'm probably going to add, I'm probably not, I'm for sure going to add more solid types, but they are all going to be collidable. So here it probably simplifies the condition here, right? So yeah, in this case, we need to check if the solid is collidable, right? We need to check this if the solid is collidable, and if it is not collidable, we can probably continue, right? Or I can actually, well, I prefer this way. I don't like to just continue too much. So if it is collidable, we just need to check the bound. First, we need to create the box of the solid, right? Because since they are grid aligned, we don't really need to keep track of it. So we can just say left x, then this is just y, and then width and height is just 1. Right? So that's the solid box, and here we can just say if check collision rex, and here we can just pass the actor box and the solid box, and if that's true, then we can just return true, right? So if a solid collides with the actor, we just return true, and here we can just return false, right? So we can probably extract all of these codes because the code for the left side and the right side are going to be the same, more or less. So we can probably just create a function, and we can say check vertical collision. Yeah, I think that's a good name. And here we just need to accept the start or the x, right? then we need to accept the start y and the end y, right? And that's it, I think. That's basically it. So here we can just copy that like so, and actually this one I'll need to move into here. Oh, and actually here I also need to accept the box, right? Yeah, so I can probably accept just the box. And here this we don't really, this can be agnostic from the actor. This can check other things as long as they have a box, so that's probably a good thing to do. Here I want to put the start y, and this is end y, it's fine. And here this is just x, and this is y, and this is x, and then y, and everything is working now. Cool. So here, I can probably add even another function. I can just say check collision, right? I can just say check collision, and this is going to accept just a box, right? And then I can check the collision. Let me think. I probably don't want this because when I have gravity, I want to know if the player collided with the um, bottom section. So yeah, I probably don't want that. Yeah, so let me not use this function. It would be nice to use it, but I actually cannot use it. So I can basically check vertical collision with actor dot box. Then the initial, the x is going to just be the actor x, right? The actor x. Then then I need the start y, which is going to be just this thing, and then I need the end y, which is just going to be that, right? So that's the stuff. Yeah. So to basically do the same thing for the right side, we just need to do something a little bit different, because here we need to check. So let's imagine we have this, right? We still want to truncate that, right? Yes, because we want to check this, because if the point was here, we still wanted to check that. Okay, so we just need to do that plus actor dot box dot width, right? And then the rest is the same, because we are still going to check the same vertical line, just shifted to the right, right? Just shifted to the right. Okay, so now I actually probably want to have a helper. I can have something like move, well, I can say actor move left, right? And here I can have actor, right? And here I want to receive a float with delta. And basically now we are going to need to do this thing that I said. So we need to split our delta into segments, right? So basically, if we are moving something to the left, the delta is negative for sure, right? So I probably want to have a constant to begin with. So this is not going to be planet, this is going to be more like yeah, I'm defining the player stuff there, so I can probably put there. Actor minimum step or something like that. or maximum step. It's actually the maximum step. And I don't know what's going to be the minimum block size in the world, but take into account floating point imprecision and already future proofing this, I'm probably going to use 0.5 or something, or 0.4. Doesn't really matter, right? So, oh, and I forgot to say something. So imagine we have a segment, a line segment, and we have the maximum step and another maximum step. And here we cannot have the maximum step, right? So what we are going to do is that we are going to divide the maximum step by 2 and we try. If it still collides, we divide it by 2 and we try. If it still collides, we divide it by 2 and we try until it no longer collides. So we basically divide the maximum step always by 2 until we get a point where it doesn't divide, or we reach the maximum step count, basically. So this is basically going to be the maximum step count, and we can put it to 8. Yeah, and this is going to be the maximum step size, right? So two different things. Right, so here we are moving to the left, so delta is negative. So we basically need, let me have, I don't have maximum or minimum, do I? Do I have max? Oh, this is part of standard lib. Since when? I had no idea this was part of standard lib. What? That's very strange. Huh. Well, we can use it, I guess. So, yeah, so basically we need a float step, right? So this is going to be our step. And here, I want to take the minimum between delta and that stuff. This is not, I can probably call it step max size and step max count. Yeah, probably better name. And the step maximum size. So we take the minimum of the two, right? And since this is negative, we actually want, so this is negative, right? So we actually want this to be negative step max size, and this needs to be the maximum, right? Right, I think. Or is it? I'm a bit confused. So if we get negative 10 as a delta, and this is 0.4, this is negative 0.4, so yeah, we need to take, yeah. Cool. So now we basically need to loop. I can say int y equals 0, I is less than this thing we just defined, because this is going to be the maximum number of divisions. Well, not really, this is actually not true. We actually need to loop through while, and here we need to have an accumulator, right? Yeah, we need to have an accumulator that begins with 0, and here we need to loop through this while the accumulator, and since this is negative, right, is greater than delta, right? Because delta is negative, so this begins with 0 and this starts to accumulate. Yeah, so that's that. So if it is equal, then it breaks the loop. Okay, so now we basically need to move the players. So I'm probably going to have another box. I can call it rectangle, new box, and this is going to be an actor equal to the actor box, to the current actor box, right? And then I can probably just say new box dot so we are moving left, so we need to change x, and we are moving to the left, so this is need to be negative, right? No, but the step is already negative, right? So We actually need to add it. And we add a step, right? Okay, so we add a step, and now we actually need to do, so if we add for int I equals 0, I is less than this stuff, so this is the maximum amount of times we need to collide. We can collide actually. So I plus plus, and here we, well, what am I doing? So do I want to do this here? Let me think a little bit. Probably. So if I do if check collision, well, actually I need to use this function, right? Yeah. Well, I can actually have a function like this, right? So check left collision, right? Nothing prevents me from doing that, to be honest. Check left collision, and here I can just accept this, and here I just return that, right? Nothing prevents me from doing this, and this is just the box. And then I can have a check right collision, and then I just copy this, right? So it's actually a good abstraction, I think. Okay, so here I only need to check the left collision because we are only moving to the left, so nothing else is needed. I think, probably, maybe. Is it true? I think it is, because let's say I have something like this, player is here, I move it to the left, it is impossible to collide. Yeah, it is all, yeah, that's true, that's actual true invariant. Okay, so we check left collision, and here we just pass a new box, right? So we check if the new box collides with something on the left side. And this inside here, well, I know, really, I can actually do that inside there. Okay, so if it collides, we need to revert what we just did. So we subtract it. We need to, yeah, I don't need this, to be honest. I can call this step size. And I can then have a int step count equals 0. Yeah, this is probably better. So here I can just check these two conditions, and it's much better. Less or equal than that, and it's just fine. I don't need this for a loop actually. Okay, it's going to simplify the logic a lot. Okay, so we basically do this, we increment that by step size, then we need to revert what we just did, and we need to divide the step size by 2, right? We just do that because in the next iteration, we are going to have a step size that is smaller, right? Yeah. So now, if it succeeds, so if there is no collision, right? So else, we need to increment the accumulator, right? Yeah, we just increment the accumulator by step size. Okay, so I think that's it. And this doesn't really return anything. This just moves the actor. So in theory, oh, and I need to increment the step count. So I only increment the step counts when I divide this. Right, this is the amount of divisions. I probably should call it max step, max div count. Yeah, it's probably more meaningful name to not create any confusion. Yeah, that's much better. Okay, so by the end of this loop, I know that I am not colliding with anything on the left, and I have moved more or less delta, right, with some floating precisions and this imprecision caused by this maximum div count. Since we are dividing by 2 always, this is probably too much. I can probably put like 4 because the first division puts it at 0.2, the second 0.1, the third at 0.05, and the fourth at 0.025. Well, 6 is probably more than enough precision, to be honest. Okay, so here the last thing we need to do is to assign the new box to the actor box, and we have just moved left, I think, if I haven't made any mistake. So when we try to move an actor, we can move it left if, right, if actor dot speed dot x is less than 0, then we know for sure that we are moving left, right? And how much do we want to move? Well, that's actually simple. We want to move the current speed times the frame time, right? So that's, my god, that's the delta of this stuff, right? Cool. Yeah, I don't think there is nothing else missing. Well, I could probably, yeah, I can probably return a boolean here, and I can have a flag collided with something that is initially false. And if it collided at some point, we just put it as true, right? And here we return collided. Because if the player collided with something on the left side, then its speed is going to be 0, right? Because it just crashed into a block, then it cannot possibly like retain momentum, right? It's like basic physics. So unless, yeah, because solids are immovable objects, because they simply don't move in this game. So this is more, yeah, this is basically always true. Right. So let's test this. Well, actually, to test this, we need here, instead of updating the box directly, we need to update the speed, right? So if the key is down, right, we basically set the speed, and we don't need to, yeah, we don't need to multiply by frame time. Yes. Yeah, and another thing I need to do is to basically check if is key up. If W is up and D is up, then my player speed, well, actually this, yeah, whatever, this is actually yes. Then I was checking the horizontal stuff, but then my player speed on X is equal to 0, right? Because I'm simply not pressing any key, so the player should not be moving. And then I can do the same thing for A and B, but for X, right? So I don't know why I put Y first here, but whatever. So that's going to work, I think. Okay, so now we only have collisions for the left stuff. So let me just put actor move, right? And yeah, so here when I do update, I can loop through all of the actors, right? By saying int I equals 0, I is less than app dot actors dot length. Here I can extract that. Well, I can't. Well, yeah, I can extract the actor by saying something like this. So this is my actor. Data I like so, and then I can just actor move, call actor move with actor. Well, I can inline this. This is not really going to be used anywhere else. So I can just say actor move. Cool. And this is going to update even actors that are outside of rendered, outside of drawing like this distance, right? Outside of the frustum. And that's a good thing because I have an idea for the server. But yeah. Okay, so let's see. Fmax. Apparently this doesn't exist, but this exists. What if Fmax F? Yeah, for floats. Okay. I build it. Let's see, please don't crash. Okay, that's a good thing. I can no longer move. I'm literally pressing keys and this is not moving. But I don't know if this is good or bad. Oh yeah, because I cannot move to the left because I'm colliding with the left. Yeah, but I also cannot move right or down or up because I don't have that implemented. So I probably want to initialize the player correctly. So where do I have my init function? It's here. So I probably want to put this above. And here, when I initialize y, I need to take out the height of the player, take that into consideration. So if now I do this, yeah, oh, it's moving too much. Yeah, but as you can see, we were able to move, I just too fast. Let me reduce the player speed. I don't know. Why is it so fast? We are multiplying by frame time, right? Yeah. And this is the delta. Okay. So let me put like 1, I guess. Oh, I know why. Because here we are adding stuff. Yeah. Because it starts slow. Yeah. So here we don't add, we just set it. Because now, yeah, the function responsible for adding stuff is the move function, not this stuff. Right, that was why it was speeding up, like accelerating so fast. Okay, now this is too slow. Let me put like 5 in terms of player speed and see where this gets us. So 5 tiles per second, that's what it means. Okay, so as you can see, we actually collided. Let me actually implement right because it's easier to test. So if I have a left and right, I can move both left and right so we can test the left and right collision multiple times in the same session. So yeah, I can basically create a function, the same thing, that says move right. And now we need to be careful because now delta is positive, right? So here I want min, right? And this needs to be positive. Here is the same, here is the same, collided is the same, but here accumulator needs to be less than delta. This is the same, and here we want to use the rights collision. That's the same, that's the same, that's the same, same, and same. Okay. So here we can have a function else if actor speed is greater than 0. So when the speed is 0, we don't even need to check anything, we can just skip. So this is basically going to skip the thing. And we can move right. Okay. And we know for sure this is positive. Okay. So let's test it. So we can move left and we can move right. So the right collision is working, right? As you can see, I'm colliding with the right. I can probably increase zoom for a little bit so you guys can see it. Where do I have zoom? Oh my god, it's in init, right? Init function is all the way up here. Let me put 20, like an absurd number, just so we can actually see if there is any gap or something, if the division is enough. Okay. So we are moving. Yeah, I don't see any gap, to be honest. So the amount of divisions we do here is enough. So we can see visualize a lower number of like step divisions. Let's put it like 2. Well, this is still enough. Maybe because the player has a width of 2. So let's a width of 1. So let's try to put a width that is slightly smaller than 1. Let's put 0.8 and see if this generates some gap. Let's see. No, it's still good. Yeah, this algorithm is quite good, to be honest. So maybe 2 is enough, but just make sure. I'm probably going to stick to 5 or something. Yeah. Right, so we can do the same thing for up, for horizontal horizontal, yeah, for up and down. That is a horizontal collision. So we need to check this horizontally. So we can create a function horizontal, so we can call it horizontal collision. We accept the box. Now the fixed thing is the y, not the x, because now we're checking this stuff, these blocks here at below it and up. So the y, we are always in the same layer in terms of y, right? We only move x. So y the same here. We want start x and x. This is going to be my x, and this is going to be my x, 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 and x. Then solid is collidal. This is the same. That's the same. That's the same. That's the same, and everything else is the same. Okay, cool. So I probably can move this here. We have this close together, and now we just want to do the same thing, but we just change a few things. So up is negative, so it's similar to left, right? So yeah, so here, if the player is here, we actually need, that's very interesting, right? Because, oh no, because if, yeah, if the player moved, we need to check the current position. So yeah, we don't need to add or yeah, we can do the same thing. So this is horizontal now. It's horizontal collision. So my initial y is going to be box y. Then my start x is going to be x, and there's x, and then width. Yeah, that's going to work. And here is the same thing, but we just swap this x by y and y height, and then we swap this y by x, x, and then x plus width. And this should work, right? This should work. So now we can copy this one because these are going to be very similar, because one is going to be negative, the other is going to be positive. So the up one is negative. We can use the left thingy. And I think this is, oh yeah, we just need to swap this by up, and the rest is the same. And here we just need to swap this by, what did I call it? This is not right. This is bottom. Well, up, down. Just to, yeah, probably left, right, up and down is probably better name. So this is up and this is going to be down. The downwards collision. It's here, right? And that's going to be positive. So yeah, that's going to be work just fine. So here we just need to check once again, but now I need to check for y. So if y is negative, we need to move it up, and this is going to be y, and it's going to be y. If y is positive, we need to move it down. Right, so this is y, and this is y. And that's basically it, I think. And we could like abstract this away, but I actually want this to have all of these directions in separate functions, because once we have gravity, I want to know when the player is colliding with the ground, and I need to know exactly, do that exactly in this function, right? In this move down function, because it's impossible for the player to collide with the ground by moving up, right? And if I want to know when the player is colliding with like a roof or something, I need to check it in this move up function, because like the top of a cave or the roof of a building can only be collided if the player is moving up, right? So this is why I want to keep them separate, because I want to have separate properties associated to them, right? So this should in theory work. So this, what have I done? Well, this is not, yeah, because I probably forgot. No, this is move up, down. What did I forget? Oh, yeah, of course. This needs to be Y. I forgot that. You also need to update it here and here and here as well. That's why it was moving on the left and right. Cannot change. We cannot forget this. Okay, so this should now work. Let's see. So yeah, okay. As you can see, it is actually properly colliding, and yeah, it's perfect. It's perfect. Right? We don't have gravity yet, but we can have it. Man, this laptop is very slow. I have some FPS drops like 74 or something, because this doesn't have a proper graphics card, right? So that's why it gets a bit slow. Let me try to do something like 144 or something. Maybe this is going to help it. I don't know. Let's see. So this kind, I don't know what graphics card does this have. Yeah, this is using Intel for some reason. Well, I have like a mobile graphics card on this laptop, a very old one, and I don't know why it is not being used. That's why it's so slow, because it's using like Intel renderer. Oh well, at least we are testing it, right? We are like stress testing this client, I guess. It basically works. Oh, this is a fun thing. Yeah, it basically can get pretty good FPS even without the graphics card. So yeah, yeah. So we have a cave here, right? And I'm pressing S, so I'm moving down. And if I, okay, this moved too quickly. Okay, why did it move so quickly? Huh. Very strange. I don't know why. If it happens again, we need to try to replicate it, but I'm not being able to replicate it, so I don't know. Maybe the laptop was just slow and we just had a frame drop or something, whatever. So yeah, I'm basically pressing down, and if I move right, as you can see, this is a cave, and it is actually fun to navigate it in. So I can imagine a player jumping like in these small blobs of stone, and it can actually get into places. For example, here it would be actually locked. It would need to break this stone block if it had a pickaxe. If it didn't have a pickaxe, then well, that's your bad luck. You need to die to get respawned, basically, or have someone to help you. Yeah, so we can basically navigate it pretty well, I'd say. Why? Oh, this is fun. Yeah, because here the player cannot move because since the player is 2 tiles high, and that's, yeah, that's because of floating precision. Hmm. One easy way to fix this, because I don't want to deal too much with floating point imprecision, is just be a little more loose in our actors, and instead of having them like so blocky, we can have them. Boy, I typed a lot of code today. We can have them like a slightly smaller, and this should going to fix the problem, I think. So let me try to find another cave. I really need to check why my graphics card is not being used. I know, like, it's a mobile graphics card, but it still should be used, no? Like, it doesn't really make sense to not be used. I don't know. So maybe it's as drivers or something. I don't know. Okay, so we found a cave. Let me see if I have another situation like the one we found. Okay, here is impossible to cross. Let me see. Here, for example, it's a good play. Yeah, as you can see, now we can fit in like one tile wide holes, and we can fit like in spaces with 2 tiles height, right? So that's probably good, right? It simplifies navigation a lot. So yeah, I'm already having fun in this game, and it doesn't really have anything implemented in it. It's already fun to like explore these caves. Yeah, I like it. I like it. So I think that's everything for today. I'm a bit tired. It's already past midnight, of course. So I am just going to end the episode for now. And yeah, we implemented, like, this is a very good algorithm. I know that Relief has a bug or something. I don't know if it is part of Relief or it's part of Windows, but when I hold um, a window like this and then I release it, the frame after I release it is going to have a frame time like very high, like 10 seconds or something like that. I don't know if it is a bug from Relief or from Windows, but it's basically like if when I'm holding the window, it functions like the game is not being updated, right? So the Relief event loop is not being run, right? It's like basically idle. And when I release it, then it starts to work again, right? And it has like the first frame after release is completely like massive, like in terms of frame time. So it's either Windows or Relief. I don't know which one it is. Yeah. So I think that's everything for today. Offline, I'll try to fix this, but I'll need to see because it would be nice to use a GPU, but whatever. Okay, so thank you for watching, and I see you in the next one.